Hey guys, welcome to ANS Solver. Today we'll be doing the concept of natural log graphs and log graph numericals, which is a subtopic in the chapter of logarithm. Okay, so before going to the numericals, we'll first learn sketching. Okay, so it has been asked few times, not that frequently, but obviously you need to know the concept. So first we'll graph something like y equals to ln x. Okay, so here you need to know that this cannot touch the y-axis, because your x can never be 0 because ln of 0 is not possible, correct? And when you take your y as 0, you basically get 0 equals to ln x. Okay, then you can use the log property, which states that log of b with the base a equals to c, which can be written as b equals to a raised to c. Correct? We learned this log property in the previous video. Correct? So I can simply write this as x equals to e raised to 0, as the base of ln is e. So e raised to 0 is basically 1. So y equals to ln x crosses the x-axis at 1. Correct? Now you need to understand how this is drawn. Okay, so this should not touch the y-axis. So it should basically be like something like this. Correct? You can draw it something like this. And you can name this as y equals to ln x. Okay, this is how you can graph this. The second type of question which they ask is y equals to e raised to x. Okay, so here you need to note that this can never touch the x-axis. Okay, because here basically you can't get 0 equals to e raised to x, because when you ln both sides, ln of 0 is not possible. So here basically your x has to be 0. Okay, correct, because your x always has to be 0. That means it crosses the y-axis. So you get your y basically as e raised to 0, which is 1. So basically e raised to x crosses the y-axis at 1. Okay, so I'll just write it here. This never crosses x-axis. Correct, this never crosses x-axis, and this never, actually not crosses, yeah, you can say crosses, actually never mind, you can write never crosses y-axis. Correct, this is what you can simply do. So now how do I graph something like e raised to x? Okay, so it's basically graphed something like this. So you have your y equals to e raised to x. Okay, simple, this is how you do it. Now the variation they can ask you is, let's say I ask something like y equals to e raised to minus x. You need to do nothing. Here also your x is 0. So your y is 1, because e raised to minus 0 is basically 1. Correct? So I know it crosses, okay, the x-axis at 1. But now because it's minus x, it starts from the opposite direction. So basically the sketch will look something like this. Correct? Where you get y equals to e raised to minus x. Correct? So these are the basic sketching which you need to know. Okay, so actually this is not asked very frequently. Obviously they are asked in paper 2. Okay, but now what we are doing next is really important, because that's what's asked more frequently. That's log graph numericals. Okay, so for this concept, there's no hardcore concept. We'll understand this via past paper question. You need to remember all your log properties properly. Okay, and some logic will be required to crack this question. Okay, so let's say this is the basically from 2020 May June paper 22, the fourth question. So here I have the variables x and I have the variables y, which satisfy the equation y equals to a into x raised to minus 2p. Correct? Where a and p are constants. The graph of ln y and ln x, the most important thing is the axis here. Okay? Is a straight line passing through the points. So they have given two coordinates here as shown in the diagram. Okay? And we need to find the values of a and p. So here I basically have minus 0.68 comma 3.02. Okay, and I have 1.07 comma minus 1.53. But now I know that normally the coordinates are x comma y. But now in this case you need to look at the axis. This is the most important. Here I have ln x and here I have ln y. So I can simply say that this thing here, okay, is ln x and not only x. It's minus 0.68 represents ln x and 3.02 is ln y, because that's what the axes are, ln x and ln y. And even this thing here is ln x and ln y. Correct? This is what you need to know. So now I have my y equals to a into x raised to minus 2b. Correct? Because I have ln, so I need to ln both sides. So I can write this as ln y equals to ln a into x raised to minus 2p. Okay, and always remember in log graphs, the axes are always ln. Okay, you need to remember that. Correct? So now what I can do is, I can use the property which states that log of AB equals to log A plus log B. Correct? So I can simply write this as ln y, which is equal to ln A plus ln x raised to minus 2p. Correct? So now basically the log property which I use here is that log of a raised to b is equal to b log a. Correct? So I can simply write this as ln y, which is equal to ln a, correct, minus 2p ln x. Correct? So I can simply just write this as ln a minus 2 ln x p, which is equal to ln y. Correct? This is what I have simply. Okay, got it? Now what I need is, I need my coordinates. So the first set of coordinates which I have is minus 0.68. Correct? I have minus 0.68 comma I have 3.02. The second set of coordinates which I have is basically 1.07. Correct? Comma I have minus 1.53. Correct? So these are your two set of coordinates. You know this thing here is ln x and this thing here is ln y. And this is also ln x and ln y because of the brackets. Sorry, because of the axes. Correct? So I can simply write this as ln a minus 2, okay, in the place of ln x totally, okay, which is here, I substitute minus 0.68. Okay, not only in the place of x, in the place of ln x, because that's the axis, into p, which is equal to ln y. I know ln y here is 3.02. Correct? This is the full ln y. So now what I can do is, on the calc, I can do minus 2 multiplied by minus 0.68, which is simply 1.36. So I can write this as ln a plus 1.36p, which is equal to 3.02. Correct? This is how I can simply write it. Correct? Easy to understand. Now what I can simply do is I can focus on the other set of coordinates which I have. Correct? So I have ln A minus 2 multiplied by I have 1.07 in the place of ln x, correct, p, which is equal to I have minus 1.53, correct. This is what I basically get. Easy to understand. Now what I need to do is on the calci I can do minus 2 multiplied by 1.07, which basically gives me ln A, correct, minus 2.14p equals to minus 1.53, correct. So now I would ask you to remove your calculator, because the next steps are totally on the calculator, because as you can see we have a simultaneous equation here which is basically ln A, correct, plus 1.36 p, okay, equals to 3.02, and I have ln A minus 2.14 p, which is equal to minus 1.53, correct. This is the the simultaneous which we have. Okay, so we can simply solve this on the calci, nothing to stress about. Okay, so on the calculator what you need to do is go to mode. When you go to mode, go on 5 where equation is written, and then go on 1. When you do that, you basically get 6 coefficient boxes, correct. You basically get 6 coefficient boxes. Okay, in the first box you need to know that your x here is ln A and your p here is y, okay, on the calci when you get your answer. Okay, so first, what's the coefficient of ln A? It's basically 1. Then the coefficient of p, which is 1.36. Then the coefficient of the constant, which is 3.02. Then again I have the coefficient of ln A, which is 1. Then the coefficient of p, which is minus 2.14. Then the constant, which is minus 1.53. Correct? So on the calci, what you can do is you can write this as 1, 1.36, 3.02, 1, minus 2.14, and minus 1.53. And when you click on equal to, you get your x, which is basically your ln A, okay, as 1.252, correct, and you get your p as 1.3, correct. You need to write A and P, okay, they are not specified any degree of accuracy, so just write this as 1.30, okay, and here you need to find A but. So you need to use a log property which states that log of B with the base A equals to C, which can be written as B equals to A raised to C, correct. So I can simply write this as A equals to E raised to 1.252, which can be written as A equals to, on the calci you can do E raised to 1.252, which basically gives you 3.49, okay, which is 3.50. So you get your A here and you get your P here, correct. So this was the first time. Even if you didn't understand the question, it's fine. We are right now doing another past paper example so that you're 100% sure. But this is basically, using log properties. But the only thing which you need to be mindful of is the axes which you have, correct. So let's move on to the second past paper question, which we have here, correct. So this is basically from 2020 May-June paper 32. Okay, so here the variables x and y satisfy the equation y raised to 2 equals to a into e raised to kx, where a and k are constants. The graph of ln y against x is a straight line passing through the passing through the points 1.5, 1.2 and 5.24, 2.7 as shown in the diagram. Find the values of a and k. So the equation which I have here is basically y square equals to a into e raised to kx. And the coordinates I have is 1.5, 1.2 and 5.24, 2.7. Now these coordinates are basically, if you see here, I have x and I have ln y. Okay, here I don't have ln x like we had in the previous question. That means my coordinate here is basically x and this is ln y. Okay, basically you just need to copy the axes. I have x here and ln y. Correct? This is what I basically have. So now because I have ln, because log graphs always have ln, I start by writing ln on both sides. Correct? So I can basically write it something like this. So now the log property, okay, which I can use here is that log of a raised to b equals to b log a. Correct? I can write this, and I can even write the property log ab is equal to log a plus log b. I can use both these properties. So first I can use this property here. So I can write this as 2 ln y, which is equal to, then I can use this property where I can write this as ln a, okay, plus ln e raised to kx. So I can now write this as 2 ln y equals to ln a. I can use this property here again and write this as kx into ln e. Ln e is 1, so I can just leave it as it is. Now I can write this simply as ln a plus kx, which is equal to 2 ln y. Got it? Now I basically have two set of coordinates. So my first set is basically 1.5 and 1.2. Correct? So I have 1.5, 1.2. Correct? And I have 5.24, 2.7. I have 5.24, 2.7. Correct? So now I basically have ln a plus k into 1.5. Correct? I put 1.5 in the place of x because I know this is x here and this is ln y because of the axes. You always need to observe the axes because that's really important, okay, or your substitution will go wrong, which is equal to 2 into, in the full place of ln y I put 1.2. Correct? This you need to be extremely mindful of. You can't write it as 2 into ln 1.2 because that's wrong, because 1.2 is the full of ln y. So now I can simply write this as ln a plus 1.5k, which is equal to 2.4. And here I can go to the next coordinate, which I can write as ln a plus k into 5.24, okay, which is equal to 2 into 2.7. So I can simply just write this as ln a plus 5.24k, which is equal to 2 into 2.7. So 2 into 2.7 is basically 5.4. Correct? So now I have these two equations, so I can write this as ln a plus 1.5k, which is equal to 2.4. And I have ln a plus 5.24k equals to 5.4. So now what I can do is I can solve this on the Calc. Correct? I can simply solve this on the calci. So I can click on mode. When I click on mode, I can go to 5. When I go to 5, I can click on 3. Sorry, not on 3, my bad. Sorry. Mode 5 and then click on 1. I'm really very sorry. For 1, you go to 1 for simultaneous and you go to 3 for quadratic. Here you have a simultaneous, correct? So I basically have 6 coefficient boxes here, correct? We did this in the last question also, correct? The process is very similar, only you need to take care of the axes. So here I have 1, then I have 1.5, then I have 2.4. Okay, basically just write the coefficients. Then I have 1, then 5.24, and then 5.4. So on the calci, simply do 1. Okay, on the calci, just write 1, 1.5, 2.4, 1, 5.24, and 5.4. When you do that and click on equal to, correct, you get your x, which is basically ln A. You get your ln A, which is equal to 1.19679, correct? And you get your k, which is basically your y, as 0. Just let me check. They needed to 2 decimal places. So just write this as 0.80. Okay, this is what you get your k as. Now we need to finalize a. So for that I can use a log property which states that log of b with the base a equals to c can be written as b equals to a raised to c. Correct? So I basically get a equals to e raised to 1.19679, which I can simply solve on the calci. So I can write this as e raised to 1.19679, where I basically get 3.31. So this is basically the value of a. So I have the value of k here, I have the value of a here. So this is basically the final answer. Okay, so basically this was the concept of log numericals. Okay, so you really need to understand this. It's really simple. Just be sure of what your axes are, and then plot or name your coordinates like this, so that you're 100% sure what to substitute. Correct? Like here we substituted. Okay, I'll just explain you the difference. Here we substituted minus 0.68 in the place of ln x. But here in this question we substituted 1.5 only in the place of x, not in the place of ln x. So you really need to be mindful of this. Okay. So with this we come to the end of the chapter of logs. It's a really important chapter. Okay, in the previous video, that's what they asked the most, the properties. It's really important. Okay, and they even ask log graphs. Okay, and sketching they ask sometimes in the paper too. Okay, so but yeah, only knowing these concepts or doing these few examples won't help. Okay, you need to understand these concepts thoroughly. You need to do a lot of practice. So once that you're done with this chapter, you can go to topic wise questions. Okay, and if you get stuck anywhere, we provide the video and pictorial solutions so that you can view them and you are doubt free and you can understand everything of this chapter and master it. So yeah, see you in the next chapter. Thank you very much.